All right, let's talk about a really huge leap forward for AI. We're moving past AI that just follows a simple to-do list to AI that can actually, well, think. We're talking about systems that can reason, that can adapt on the fly, and can even catch and fix their own mistakes. So let's get right into it.
You know, for the longest time, building an AI application felt a lot like writing a recipe. You'd have this very clear step-by-step process. Step 1, grab this document. Step 2, pull out this piece of information. Step 3, write a summary. And you know what? For a lot of simple, straightforward tasks, that worked great.
But here's the thing, real intelligence, the way we think, it's not a straight line. It's messy, it's a loop. A truly intelligent agent has to be able to try something, look at the result and go, that didn't work, let me circle back and try something else. That kind of creative, iterative process completely breaks a simple one-way script.
And that brings us to the big architectural problem, right? How in the world do you build an AI that can actually think in cycles?
So frameworks like the original LangChain were amazing at building what's called a Directed Acyclic Graph, or a DAG. Now the key word there is acyclic. All that means is no loops, no cycles. The flow of information is a one-way street. It only ever moves forward. And while that's perfect for a lot of things, it's a major roadblock for building agents that need to reason and retry.
This is exactly the problem LangGraph was designed to solve, and it's a real game changer because it completely reframes the problem. It says, let's not think in straight lines. Let's think of our workflow as a dynamic state machine, which really boils down to 3 core concepts. First up, there's the state. The easiest way to think about this is as the agent's shared memory, or its brain. It's this one central place that holds a perfect, real-time snapshot of everything that's happened and is happening. It's the single source of truth for the entire system.
Next, you have the nodes. Okay, so if the state is the brain, then the nodes are kind of like the hands. They're the workstations. Each node is just a function that does a specific job. Maybe it calls a language model, maybe it uses a tool. It looks at the current state to get its instructions, and then it just gets the work done.
And finally, we get to the edges. And this is where the real magic happens. Sure, on the surface, they're just the lines that connect the nodes, the pathways. But there's so much more than that. The edges are the agent's decision points. They don't just connect A to B, they are the explicit logic that defines why the agent chooses to go from A to B.
And that brings us right to the secret sauce of this whole thing, conditional edges. They are the absolute key to creating these dynamic, smart loops that really define what an advanced AI agent can do. In the code, this is handled by a function called addConditionalEdges. It's pretty simple when you break it down. It just needs 3 things. First, a source node, which is just asking, where does this decision start? Second, a path function, which acts as the little brain of the decision. It looks at the current state and makes a choice. And third, a path map, which is basically a GPS. It takes that choice and says, okay, based on that, you're going to this node next.
Now, the order this happens in is super important. Check this out. First, the node runs and does its thing. Then, its results are used to update the global state. And only after the state is fully up to date does our decision-making function get called. This is so critical because it guarantees every single decision is based on the absolute latest information, which makes the whole system way more reliable and, frankly, a lot easier to debug.
Okay, so that's the mechanics, the nuts and bolts of how it works. But the really exciting part is what this lets you do. So let's check out some of the incredibly powerful agent patterns you can now build.
The most fundamental pattern for any agent, the absolute bread and butter, is simply deciding when to use a tool versus when to just give a final answer. This is really the core of that classic agentic loop.
This is what's known as the react loop, for reason and act. The agent generates a response or a plan. Our conditional edge then inspects that plan. Does it see a request to use a tool? If yes, it routes the workflow over to a tool node. If no, then great, we have our final answer, and the job is done. It's a beautifully simple and effective way to make a decision. But what if we want to get even smarter? We can use the same idea to build an agent that can actually critique and refine its own work.
So imagine an agent that writes a piece of code. Then, its output gets sent to a second critic node, whose only job is to evaluate that code. Is it good? Does it have bugs? Based on that review, a conditional edge makes a call. If the code is good to go, we're done. If not, it loops right back to the original node to try again.
This creates this incredible feedback cycle where the agent can just keep improving its own work.
Now, this next pattern is so incredibly useful, especially for high-stakes tasks where you just can't afford to let an AI have full autonomy. You can actually build in a pause for human supervision.
You can literally design a node to just stop and wait for a human. The agent proposes a plan like, hey, I'm about to do this thing. And you, the user, get the final say. You can approve it or reject it. Then a conditional edge takes your input and directs the workflow based on your decision. It gives you the ultimate control.
Okay, so these patterns are obviously really powerful. But if you're going to build this stuff for the real world, you have to think seriously about your architecture and maybe more importantly, how you're going to debug these complex, cyclical systems when things go wrong.
And this comparison table really spells out why the LangGraph approach is such a big deal for agents. I mean, sure, you could just bury your logic in a bunch of messy if-else statements, or use a simple router. But with those methods, your control flow is either hidden or it's stateless. LangGraph makes the control flow explicit and stateful, which means you can actually visualize and trace the agent's decisions, and that makes debugging 1,000,000 times easier.
So the big takeaway for building robust agents is that you have to be intentional. You need to carefully design your state. You need to make sure every node has one and only one job. Your decision-making functions should be clean and predictable. And critically, you have to make sure there are no dead ends. Every possible branch has to have a clear path to completion, even if that path is just to an error-handling node.
And all of this really points to a fundamental shift in how we build AI. It's not just about adding loops. It's about making the agent's reasoning process, its decision-making logic, a visible, designable, and central part of the entire system's architecture.
What this new paradigm really gives us are the tools to build genuinely controllable cognitive architectures. We're moving beyond simple automation and into a new era where we can meticulously design how an AI thinks and makes decisions. So the only real question left is, with this kind of new power, what will you build?